Day 28, projectiles, problem 29. Here's the diagram. You're throwing a rock at a 30-degree angle, or an object, I guess it's a rock, stone, from 30 degrees below the horizontal from a tall bridge. Once again, if you draw a diagram and you label your points, I have point A up at the release point, which is the typical case where you're starting a problem. I have point B down here where it strikes the ground. It'll be a projectile following that dashed path, but the initial direction is, according to the vector arrow there at the beginning, 30 degrees with respect to the horizontal. And what you'll do is you'll calculate the components of that vector, and it's a 30, 60, 90 triangle, so you could take some shortcuts. The short leg of the 30, 60, 90 would be v sub y. It's going to be half of 25, which is 12.5. But the key here is that's negative 12.5. I don't know if I can fit that in here. And that's meters per second. And v sub x would be the 12.5 times square root of 3, which is 21.7 meters per second. So you would plug those in for v sub x and v sub y. In other words, you now know specifically this value, which you really aren't going to use. But more importantly, you'll use the v sub I in the y direction, which is the negative 12.5. So right up here, you'll plug in the negative 12.5 as your vertical component. It's important you plug in negative 12.5. You're given that it takes 2.5 seconds for the rock to hit the water or the ground, and the standard acceleration rate of negative 9.8 meters per second squared. Those are all standard units. So you could use one of the four acceleration equations to figure out s, the height there. This s then is what you're looking for. You could find v sub f if you wanted to as well. The velocity, the vertical velocity with which the rock hits the ground or the water. That's the basic setup for that problem.